This is the most important issue of humanity like ever, the risk of a hothouse Earth, because that's completely unsurvivable. We cannot survive a hothouse Earth. The paper explains very well, as the 2018 did, that the risk is determined by the feedbacks, multiple amplifying feedbacks.
Hello, and welcome to another edition of the Climate Emergency Forum. I'm Herb Simmons, the author of A Climate Vocabulary of the Future. You know, we've been on for a few years talking about the climate emergency, and I suspect that maybe the most emergent of the emergencies is the degree to which the climate remains in the control of humanity. And more evidence seems to suggest that's a questionable assumption. And recently, just last week, a commentary came out in a publication called One Earth entitled The Risk of a Hothouse Earth Trajectory. And what we thought is we would focus today on this commentary and talk about it and what's behind it and what it means. I'm just going to read 2 or 3 sentences from the abstract to set the stage. It starts out by saying Earth's climate is now departing from the stable conditions that supported human civilization for millennia. Crossing critical temperature thresholds may trigger self-reinforcing feedbacks and tipping dynamics that amplify warming and destabilize distant Earth system components. We are leaving the stable conditions of the Holocene and entering a period of unprecedented climate change beyond the natural interglacial envelope with outcomes that are difficult to predict. A very sobering message and one that we'll talk about. But first, I want to encourage everybody to like our channel, to subscribe, to go to our website, climateemergencyforum.org. We would appreciate your donations. Leave us your comments, your suggestions for future programs. And at the end of this program, as at the end of all of our programs, we hope you'll stay to the end, as I'll be focusing on what we call the Climate three of the big stories that have made the news in the past week. With that, we have our 2 regular panelists, Peter Carter and Paul Beckwith. And today, welcome, Peter. Welcome, Paul. I'd like to start with you, Peter. Floor is yours.
Thanks, Herb. So this is really my favorite horrible, nasty topic on climate change. So I'm very glad that Bill Ripple and colleagues published this paper, because hopefully it reminded the world that we are, in my view at least, on track. Our trajectory is towards hothouse Earth. The last time this was covered, and it was covered very, very well indeed, was in 2018. And that was by the late Will Steffen and colleagues. To me, that's the most important paper ever. And this one complements it very well. So the media picked it up slightly, The Guardian and The Independent in the UK, but I didn't see anything else in the media. This is the most important issue of humanity like ever, the risk of a hothouse Earth, because that's completely unsurvivable. We cannot survive a hothouse Earth. The paper explains very well, as the 2018 did, that the risk is determined by the feedbacks, multiple amplifying feedbacks. I want to mention, the paper does mention that present commitments have us on course for 2.8 degrees C, and that's way above a trigger for a hothouse Earth. The 2018 paper came down with 2 degrees C as the risk, the threshold that could trigger into a hothouse Earth. So that's still very, very important, because we are definitely on track for 2 degrees C and on track for 2 degrees C very soon. James Hansen's latest communication was to expect 2 degrees C in the 2030s, not 2050, which is what we had all assumed before. So They mention all the tipping points. So in addition to the amplifying feedbacks, many of which are tipping points themselves, they mention several other tipping points, and that's just fine. They don't mention carbon sinks, and that's really important because carbon sinks absorb about 50% of our CO2 emissions, and there are signs that they're beginning to lose efficiency. So that is a huge risk contribution to Hothouse Earth. I was frustrated, as I often am, that they did not mention summer sea ice. They only had winter sea ice. And this has sort of been the way that the science has gone for several years. And obviously, it's complete nonsense. The IPCC has said that sea ice was reversible. No, to put everything in a nutshell, the problem actually comes from the loss of the sea ice, because the sea ice is the tipping point of all tipping points, because it boosts all the other ones. It boosts the permafrost thaw, methane and CO2. It boosts the peatlands and wetlands subarctic, which actually wasn't in this paper, but that's considerable because they are now being activated. And also, of course, Greenland ice sheet. The paper does mention AMOC. I think quite rightly said, that that's a low risk, but it's a long-term risk. However, recent research suggests that it might be a lot worse. The trigger of AMOC may be just decades away, even though an AMOC collapse would not happen for hundreds of years. Now, this paper was actually good on that because it took us beyond 2100. It took us to 2300. The limit of 2100 that the IPCC and the science gives is a big mistake, because things don't stop at 2100. They continue for hundreds and hundreds more years. I want to mention the IPCC AR6 because it's so very simple. If you go to the reasons for concern, called the burning embers, you'll find large-scale singular events, and you can see that they start at 1.5 degrees C, and they are high risk at 2 degrees C. My message would be that 2 degrees C is what this paper calls the point of no return. They do mention the point of no return, and that's what we have to avoid, and that means stopping fossil fuel emissions and other emissions on an immediate basis.
Thank you, Peter. Let me turn it over to Paul Beckwith. Good to see you, Paul. Floor is yours.
Thank you. I'd like to just, echo some of Peter's thoughts. He mentioned James Hansen's work. It's great that Bill Ripple and his group put together a paper like they just released on a regular basis. So this is not their first work. Every year they're publishing and updating their findings. If you look at the acceleration of climate change and warming, we're experiencing temperature increases of about half a degree per decade. So we're at 1.5 Celsius essentially. So you can just do the math. We'll be hitting 2 degrees roughly 2036 or so. That's according to Hansen and some other papers. But the main consensus, the IPCC, et cetera, they say 2 degrees by more like 2050, but I think their numbers will be updated the next time they publish reports and so on. So if we reach 2 degrees by 2036 in 10 years, we're going to reach 2.5 by 2046, and we'll reach 3 degrees Celsius by about 2056. And there's nothing to say that linear increase of 0.5 degrees a decade won't change to something even more as there's more and more tipping points put into question. Of course, this is assuming that we just continue on business as usual and don't deploy solar radiation management to cool the planet, because we all know that a large volcano goes off, planet can cool a half degree or a degree for 3 to 5 years. I've just picked up a couple books that are relevant, trying to have some optimism in the face of this dire news. And one is called Positive Tipping Points by Timothy Lenton, just published in 2026, and I picked up a copy yesterday. And then the other book was Clearing the Air by Hannah Ritchie, data scientist. Just picked up that book yesterday, and I think, one of the really bright spots is, with all the nonsense and climate change and misinformation coming from the US. A very bright point is what China is doing. They're not talking, they're just taking action and just building tremendous infrastructure for solar and wind and battery storage and electric cars. Basically, with some of the US policies, which we'll be talking about in a subsequent video when we talk about retreat from climate action, and I'll just touch on that. I mean, this report, as Peter said, the Bill Ripple report and Hansen reports should hit top of the line news and be on talk shows and be covered widespread by legacy media, not just be a story, sort of a flash in the pan. The paper's published, there's hardly a peep in mainstream media. And this is part of an ongoing thing that's happening. If you remember back to 2021, a climate emergency was declared by many countries, et cetera. But you can't maintain the state of emergency. I mean, a state of emergency, it has a shelf time. If you declare an emergency and nothing's really happening, a few things are happening maybe personally, but if your life continues and years later, I mean, you think, was it really an emergency when it was declared? So it's part of the way we respond to stress. Like if there's a stressor on an individual, you're stressed initially, but then eventually your body, you kind of accept that something's different. You don't maintain a high level of stress. I mean, we have a fight and flight sort of thing within our human nature. You see an animal, a bear in the woods starts chasing you, the adrenaline picks up and you get this agitated state, but there's no way you can maintain that or it would kill you. So you kind of get used to it. And this is what's happening because reports on climate change and the urgency have dropped significantly in the media since they peaked in about 2021. So it's all part of the reason why this paper hasn't had the visibility that it should have. I mean, it's, as Peter says, it's crucial information. So why is society continuing to ignore it, I guess?
Thanks, Paul. And I think what you're what you're raising brings up the issue of the relevance of the Climate Emergency Forum. If in fact sort of we're burning out our nervous systems, I agree with you. Emergency is a defined period of time as opposed to what often people are calling the long emergency. So what I want to ask the two of you, I want to try to get back to, it's really important we try to hone in and define as clearly as we can for our viewers what in the world we mean, and what in the world, more importantly, the authors mean by the title being the risk of a hothouse Earth trajectory. So they say the risk. They don't say we are in a hothouse Earth trajectory. They start by saying the Earth's climate is now departing and use similar language. So the train is sort of leaving the station, if you will. Can we be more specific? Does science allow us to be more specific on this existentially critical question? Let me start with Peter.
This paper in Science in General actually doesn't do risk because it does probability projected by models. It doesn't include magnitude. The actuaries, the Association of Actuaries in the UK, they have a proper climate risk index, and it's published every year. Those are unpublished here. So we have to get onto that because that makes the risk hugely increased, massively increased. As Paul said, yeah, we're going to be at 2 degrees and more than 2 degrees. That puts us on a hothouse Earth trajectory for sure. And our emissions, and this paper does mention emissions definitely put us on a hothouse Earth trajectory.
Okay, so let me just turn it back to Paul. First, I want to say that we did do a program some months ago on the actuaries report. So we're focused on it. And I agree with Peter how important and how that has a different framing. And I think the distinction, as you point out, Peter, between risk, and probability is very important. But Paul, any response to what Peter said or my question?
Of course, risk is the probability of occurrence times the impacts if the actual thing occurs. And the impacts are the entire planet, right? The impacts are enormous. And up until recently, the risk has been very small. So This is why the uncertainty is so high. Multiply a small number by a large number, there's huge uncertainty. But the climate risks are increasing more and more, and therefore the risks are going way, way up. And humanity's response is very, very weak thus far. This is why the hope I have is that we will go to ways to cool the planet on a large scale. And many people are against that, but it's being talked about more and more. We're seeing the impacts. We're seeing extreme weather events. We're seeing places flooding and wildfires. And, you don't have to look very far or very long to get billion-dollar disasters somewhere in the globe due to extreme weather caused by climate change.
Great. Thanks, Paul. Let me turn it back to Peter for the sort of the second part of our program and give us some more your perspective on this paper and the larger implications, of which there are enormous implications, as you pointed out, Peter.
Well, the implication, and of course, scientists are not allowed to say anything like this, is that we're on a global suicide scenario. That's the implication. The control that is being exerted by governments and corporations is a powerful control, and that control is increasing our emissions every year. So that increases the acceleration of global warming. And the main point, I think, is the acceleration that was in the paper, and they put numbers on it. And since mid-century, global warming rate has increased sixfold. So global warming now is 6 times faster than it was. And also the great Forster and team update, they again have said that the rate of global warming is unprecedented in our record. So
You said something a minute or so ago that perked my ears up. You said global suicide scenario. I don't say this tongue in cheek. I say this with my tongue outside my cheek or inside, wherever it's supposed to be. I literally think that the IPCC should label one of its scenarios in its next round. Let's be honest about it. You have all this scientific jargon that even those of us who aren't scientists and try to understand it often takes us years to understand about SSPs and 2.1 this and that and all the rest of that. But I will urge us to ask them to do a global suicide scenario and see how close we are to it. What do you think about that, Peter?
yeah, that's excellent because, they're always changing the scenarios. The scenarios are difficult enough to understand. Every 5 years, they change them, so we have to relearn the scenarios. Their projections don't really change at all. So the scenarios back in 2001, we can use those, and we're still on this suicide scenario. So I really agree with you that we must at least have one scenario that people can understand. And I suggest two scenarios: what we can do in the best case, in which we put all our efforts into immediate, that would be useful, but also the worst case should be called the suicide scenario because that's where we're at. That's what our governments are doing.
Yeah. Well, maybe we ought to think about starting a campaign or urging our viewers to start a campaign, a plain English or whatever language they're familiar with campaign for the COPs and the IPCCs and the scientific journals. This is too important to obscure with obscure language. With that, let me turn it over to Paul.
Yeah, I mean, in your next edition of Climate Vocabulary, you can add this scenario. And I mean, the jargon they changed to for the scenarios was these SSPs, shared sustainable pathways or whatever. So it's really obscuring the issue. People often ask me, what do you think is going to happen over the next 5 years? And if you look at what Hansen is talking about, let's look back a couple of years. We had a strong El Nino. We hit 1.6 degrees Celsius above pre-industrial. It weakened a bit. We backed off to about 1.4, and then the previous year we had 1.5. So the last 3 years on average, we've been over 1.5. So what's going to happen? We've been in a bit of a La Nina, the cooling version, and all signs are pointing to another El Nino returning towards the end of this year. And if that happens over the next few years, we're going to rocket up to probably 1.7 or 1.8 even. Probably with the fluctuation, we'll reach that 2 degrees by mid 2030s in about a decade. But I think in the next couple of years, we're going to see some big swings and huge record temperatures. And One of the reasons for the uncertainty in these forecasts is that we're having a lot more difficulty predicting El Niños and La Niñas. So there's a professor at University of California, Irving, Yi Yu, who's been studying ENSOs for decades. And I attended a talk just earlier today, actually, called The Changing El Nino in the 21st Century. So in the 20th century, you typically have a La Nina, an El Nino, La Nina, El Nino, and the change would be, every 3, 4, 5 years, 2 to 7 year cycle. And the El Niños were mostly the warming water off South America. Well, now what we're seeing is the pattern seems to have changed, and the warming water is mostly in the central Pacific. It's not developing off the coast of South America. It has to do with the Walker circulation reacting with the ocean temperature in the 20th century, and now it's more like the Rossby waves, jet streams are interacting with the water. So the characteristics of the ENSO have changed. I don't think there's any question. So it's become more difficult to predict. And what it means is that we can get back-to-back El Niños. We can have an El Niño and then another one and another one without the intervening La Nina cooling period. So it's becoming more erratic and harder to predict. So it really looks like we're going to be setting new temperature records globally in the next few years. So that adds some uncertainty, but this is a signature that's on top of the overall warming, which is continuing as long as greenhouse gases continue to skyrocket up, which they're doing. I mean, we're setting new records. The curves are concave up, not concave down. We're not slowing down, we're speeding up. Whether the media talks about it less or whatever, the climate doesn't care. We're skyrocketing upwards at very rapid rates.
Well, yeah, you're describing the kind of additional complexity of this other forcing that you've just described. I want to sort of ask both of you, again, our viewers are watching and listening and scratching their heads if they're still saying, if they're, still here, if they haven't just left for the nearest bar or pub to, sort of try to minimize the pain of what we're saying, the implications of what we're saying. But it's one thing for us and many, many other people to be exhorting governments and everybody to, reduce fossil fuels. But my question to the two of you is what is the realistic impact? Let's say over the next 10 years, we actually start reducing emissions, not at some kind of magical level, but at least, a much more aggressive amount than we have the past 20 years. Will that make any real difference on the hothouse trajectory? Or will we need, as Paul has said, and I tend to agree with you on this, Paul, strongly, that the answer without ignoring emissions is direct cooling through various means of sunshine reflection and so forth. But, what can we expect? Are we sort of past the point where emissions can do much good? Let me start with Paul.
Yeah, I think there's going to be a lot of short-term pain. And I think that short-term pain may actually propel some action. And I'm talking about things even like inflation, food inflation. Prices of food have skyrocketed just in the last few years. And, some people say, well, it's the economy or it's this or that. But the root cause of the food inflation is reduction of production. And that reduction of production is from climate change, extreme weather events. So the latest, as of yesterday, I just read an article that coffee, which originated in Ecuador, many years ago, many thousands of years ago. We're going to run into extreme scarcity due to climate events, weather events, and therefore prices will continue to rise at much faster than inflation rates.
Can I
Yeah,
just sort of
yeah.
interrupt? We've talked about these before, and I think it's really important. I think we all notice at the grocery store. My question more was, what realistically can an aggressive regime of successful emission reductions over the next whatever number of years, 10 years, 15 years, can it make a noticeable difference in avoiding or minimizing this hothouse Earth trajectory? Or are we at the point where emission reductions, because of all the things we've talked about for
Yeah.
years here, still need to be done? It's not being complacent and saying don't do them, but that the impact will be not enough to sort of get us through this.
I'm 100% convinced that we need cooling of the planet to buy us time to do these emission
Mhm.
reductions to avoid crossing tipping points. If we just do emission reductions alone, I think we're going to be crossing a whole bunch of these tipping points, and it's going to propel us to a much warmer, more dangerous world.
Well, that's succinct and clear. Peter, your thoughts on that?
Well, I can answer your question directly because the IPCC AR6 actually specifically answers it. And it may be quite surprising, especially to some experts. So they answer the question, what happens if we initiate an immediate, strong mitigation? And what happens is that the global temperature only slows down. So it doesn't stabilize for 20 to 30 years.
Hmm.
So that is the commitment that we have to bear in mind and make a priority in all our policy making. And of course, that's not being done at all. On the still controversial issue of geoengineering, well, at the minimum, we have to cool the Arctic because I've already mentioned the Arctic sea ice, and when that goes, there's a huge increase in radiative forcing in the Arctic and maybe some globally as well. And that's pushing the methane and carbon dioxide from the permafrost and the wetlands even faster. And once that starts in the permafrost, that's irreversible. You can't go back on that. Apart from, I guess, cooling the planet, but no geoengineering is going to work unless global emissions are in decline at the same time. And the reason is that you're still piling heat into the oceans, and we've got this unbelievable amount of heat in the oceans, which is accelerating. It's going all the way to the bottom of the oceans now. So you need a Manhattan Project. That's my view,
Yeah.
because we need more technology, we need more science.
And so what I'm hearing from both Peter and Paul is that we need both. We need everything. It's all hands on deck. It's not everything indiscriminately. Some things may have disastrous side effects, but we need direct cooling. We need aggressive emission reductions. We need aggressive carbon renewal. What Paul, you have characterized as the three-legged bar stool. I call it the triad. There's lots of different terms for it, but it's everything. And in the absence of everything, is it fair to say we'll have nothing in a few decades, or at least nothing that reflects or is anything similar to the life that those of us on the planet are living right now? With that, I want to thank Peter and Paul for really how much more important can a discussion can be, even though we've just scratched the surface on whether we're entering and what we can do about a hothouse Earth trajectory. And at this point, I take a couple minutes, as I always do, take 3 minutes, 1 minute each on three of the big climate stories of the day. And first, let me go to a country with the name of Ethiopia. And while this is not something that immediately occurred, there was a story about it recently that Ethiopia is the first nation on the planet to ban imports of fossil fuel vehicles. First, they did it with cars, and then a few months ago, they did it with trucks. Yes, it is a full, complete, total ban. They did it as much for economic reasons. They were spending $6 billion a year on fossil fuel, and that money now stays in the country, or at least most of it does. But I think when people say, "Oh, well, that's impractical, that's this or that's," go to look at Ethiopia and see what they've done and how they've done it. So that's number one. And number two, here we go, is we mentioned just a few minutes ago about 3 degrees of heating were coming our way. Well, there was a story in The Guardian just a day or two ago. The European Union's Climate Advisory Board has called for the countries in the EU to prepare for a, quote, catastrophic 3 degrees C of global heating. A member of the Scientific Advisory Board said Europe was already paying a price for its lack of preparation. It's a daunting task, but they said it's a doable task. It's not rocket science. Reuters notes that climate change has made Europe the world's fastest warming continent there. And so here we have a situation where we have to prepare for this. At the same time, we can't be complacent and give up on emission reductions and everything else to try to minimize that consequence. But it's coming, and it's, as you guys have talked about, it's here sooner rather than later. Interestingly, we've talked before about the endangerment finding that Donald Trump, our president of the United States, basically is trying to eliminate so that we won't be able to regulate carbon dioxide. Well, there was a story also in Bloomberg about how the oil and gas companies may do worse by doing that because that provided some predictability. If that endangerment finding goes away, and we won't know for sure for many years as a result of court decisions, oil and gas companies will be subject to all sorts of lawsuits that they're protected against right now and regulations by the states in the United States. And we have this crazy situation where half our states are aggressive and will regulate, and the other half will look the other way. So all these things are maybe not quite as simple as we seem on the surface. With that, let me thank our conversation today, our Peter and Paul. We hope that you will like and subscribe to our program, and we look forward to seeing you next week. Thank you very much.